in the last lesson, we learned how to, add polynomials, subtract, multiply. Today we're going to talk about how to divide them. So take a look at this problem for a minute. You have a fraction here, right? In the numerator of the fraction, how many terms do we have? We have 1, this one, 2, and 3. That is a polynomial, 3 terms. How do I know there are 3 terms? Because they are divided by what? The plus and the minuses, right? They're separated by the pluses and the minuses. So here we have a polynomial, and on the bottom we have a monomial, right? To do this, so to divide a polynomial by a monomial, we have to divide each one of the numerator with the denominator. So for example, this is what we do. However many terms you have here, that's 3, you have to create that many fractions. So 1 minus minus, the second one plus plus the third one. Okay? Do we see that? We just split everything. And now, the first polynomial goes here. The second one, you guessed it, goes here. The third one goes here. On the bottom, you only have one denominator, so you just duplicate the same one over and over and over. Are there any questions on this step? Now this becomes the same exact thing as you were doing in the homework. We just have it 3 times over now. All right, so here was that homework. Oops. Oh, I must have closed it. Oh, no, it's here. Okay, so now we have a similar situation as, let's say, number 8, but 3 times over. Okay, so that's what we're going to do right now. Okay, so same skill as before. All right, so for the first one, the 20 and the 4 gives me a 5, right? I have C to the 3, D to the 1, and the F's go away. Yes? Okay, because 2 minus 1. Okay, now 6. No, actually you don't write the 1. I'm just writing it so you guys can see. Okay, but we just write it like that. So here, 16 and 4 gives me a 4. C and C go away. D and D go away. And it's F to the power of 1, which is just F. Plus, these all cancel. So is it just nothing there? What do I put instead? A 1. Okay? Right? You can never divide 2 things and unless one of them is 0, you can't get a 0. You're going to get a 1 if they all cancel. And that's it, right? But do you see how the first step is the most important? That's where students mess up because they forget that they have to split it up. Once you split it up, you literally divide and conquer. And look, even me at this age, when I'm doing this, I only focus on 1 at a time. Okay, just divide and conquer. All right? Okay.
We're supposed to try and divide this?
Huh?
We're supposed to try and divide this?
Yeah, but we're going to do it together. Okay, so what if on the bottom you didn't just have a monomial? What if you had a polynomial? What then? Well, then you have 2 ways of doing it. Either long division or synthetic division. Okay, do you guys remember long division? You learned it first in the 4th grade. I know that because I have a son in the 4th grade now and he's learning it this year. So that's when you first learned long division. And now you have no idea how to do it again. But we're going to do this together. Okay, so look. Okay, so 789 divided by 4. So remember the 4 goes out here. 789 goes over here. Yeah? Okay. So now, here's what we do. We take the 7 and the 4. How many times does 4 go into the 7? 1 time. So I put a 1 here. What do I do then? Multiply 1 by 4. So I get a 4. Then what? I gotta subtract. I gotta minus, subtract. So when I subtract, okay, before I subtracted, was this a positive or a negative 4? Positive 4. To subtract, this becomes a negative 4, right? And then I just combine them. So what do I get there? Okay, you need to be with me. Okay? 3. Then you bring the 8 down and the whole thing starts over. Okay? So now 4 into 38. How many times? 8? 9. 9. 36. We subtract. I get a 2. Oh boy. I bring down the 9. 4 goes into 29. 7 times. 28. Subtract. I have a 1 here. What is that 1 called? Remainder. Okay? So the quotient, that's the answer, is 197. The remainder is 1. So that process is important. This divided by that, put the number up here, multiply, subtract, repeat. Why can't we just do that? Okay, because now you're going to do that with this, with polynomials now. Okay, so this x minus 3 goes out here. This goes in here. Okay, so do you remember here what we did? The first number divided by the outside number. That's what we're going to do here. The first number divided by the outside number. And you know what? I'm going to use my scratch paper for this. What does that give me? X squared over x gives me what? Just x. So I put that number x up here. Now, after I did that, after I put the number upstairs over there, what did I do? I multiplied everything to the left by that number. So x times x, x squared. X times negative 3, negative 3x. All right? So first put the number up there, then multiply. Now it's time to do the subtracting part. To do the subtracting part when it's a polynomial like this, okay, there is a, like a little, it's draw the line, change the sign, and combine, right? Remember how when we were subtracting the 4 here, it's like it became like a negative 4? So you're going to draw the line, you're going to change the signs, and you're going to combine. So x squared and negative x squared goes away. It's always going to go away for that first one. 7x plus 3x, 10x. Now I bring down the minus 30. Ella, you with me?
Wait, how'd you get
Sit
the
up.
3x?
Huh?
Where'd you get the 3x?
Because whatever red number goes up here, you have to multiply by all of these. So x times x, x squared. X times negative 3, negative 3x. Okay, now, same thing all over again. First number by first number. So 10x over x gives me a 10. So here I put plus 10. Multiply all of this. So I'm going to get 10x minus 30. Now, draw the line, change the sign, and combine. 10x minus 10x goes away. It's always going to go away. Negative 30, positive 30, what does that give you? 0. So what's the remainder? 0. But my answer is x plus 10. Isn't that fun? Look at that 4th grade long division with a twist becomes 11th and 12th grade polynomial long division. How cool is that? Right? So my 4th grader sees me doing this on my material and stuff, and he's super excited to get to learn this. Can you imagine being a 4th grader and seeing what you're doing applied to all this complicated stuff? It seems so cool for him, right? Huh? No. Nobody does this in the 4th grade. But you were doing this in the 4th grade. Right? This one.
I wasn't.
You were. I promise you were. You went to school in the 4th grade, didn't you? This is what you learned then. I promise. That's where you learned it.
I didn't learn.
You guys all learned long division.
Well, we didn't learn.
No, I remember. I specifically remember I missed today and then I failed the whole.
You blocked it out of your memory. You all learned it. Okay. All right. Okay. Huh? Then you did division. I promise you. I promise you. Yeah. We're going to agree to disagree on this, but I know I'm right. You all learned how to do this. Okay. So this is written in a different form, but this means the same thing. So we're going to take the x minus 1, put it over here, and we're going to get x squared minus 13x plus 11. Okay, same thing. This over that. Always go on your scratch paper.
What about the exponent?
So that means the same thing because look, this had a division sign. This has times to the negative 1. That means the same thing. Okay. All right. X squared over x will give us x. Here, multiply all of this by that number. So it's x times x, x squared, x times negative 1, negative x. Draw the line, change the sign, and combine. So we get this go away. Here we get negative 12x. Bring down the positive 11, and the algorithm starts all over again. Okay? So, negative 12x over x equals negative 12. That goes up there. Multiply everything by that. So we get negative 12x, positive 12. Draw the line, change the sign, and combine. Negative 12x, positive 12x. This first term is always going to go away. If it didn't go away for you, remember, we are just human and the math is always bigger than us. So if that didn't go away, it's not that the math is wrong. We made a human error. So you have to go back and you have to see, where did I go wrong? Okay? So 11 minus 12, what does that give me? Negative 1. So now this is my remainder. Okay, so my answer is going to be the quotient, which is x minus 12, plus the remainder over the thing we put on the left. Okay? If you're ever on Jeopardy, this thing here is called the divisor. So you put the remainder over the divisor. Okay? And that's how you write your answer. Isn't that cool? So we did one without a remainder. We did one with a remainder. All right? Fabulous. Okay. Let's do one more. Okay, so what goes to the left here? X plus 1. And inside I get 2x cubed plus 3x squared minus 4x plus 15. Okay? All right. So 2x cubed over x. What does that give me? 2x squared. I put that up here. And you have to multiply everything to the left by that. So 2x squared. Oh, no. 2x cubed plus 2x squared. Draw the line, change the signs, and combine. This goes away. And what do I have left? How much is that? 1x squared. And then the negative 4x comes down. Okay. This divided by this, what does it give me? X. So plus x. Okay, now I'm going to multiply everything on the left by it. So x times x, x squared. x times plus 1 plus x. I have to multiply everything to the left by that number x. Right.
Yeah, how do you get the second number again?
Huh?
How do you get the second number again? The x.
Okay. This, how do I get that?
Yeah.
Okay, so once we got here, you always have to do the first number by this number. X squared over x gives me x. Okay, now draw the line, change the sign, and combine. That went away again. Oh my God, magic. But it's really not magic. It's the math, right? So what do I have underneath? Josh, what do I have underneath? What do I have left here? What do I have left here? Negative x, just 1x? Huh? Negative 5x, right? Negative 4x minus x is negative 5x. Bring down the 15. Okay, divide this by this. Negative 5x over x, negative 5. So put that over there. Okay. Somebody tell me what I write on the line below now. Okay, negative 5x minus 5, is that right? What do you guys think? No. Then what is it? Well, tell me, what am I supposed to do? What am I supposed to do? With that negative 5 that I put here, what do I do with that? I have to multiply the left with it. So negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. You were right. I just wanted confirmation from others. Okay? So, changing the signs. This goes away. 15 plus 5, 20. That's my remainder.
So then you do, so the answer is 2x squared plus x minus 5, and then it's the remainder, so 20 over x plus 1.
Correct. Okay? Okay? All right. So, now we're at the point where when I do it, it just seems so easy. And you can all follow along and you kind of get it. But now after this, we need to get you to the point where you can do it without me whispering in your ear how to do it. What's the one way to do that? What's the word? Practice. Lots and lots of practice. What if there was another way? So this process is called long division. What's it called? Long division. Now, there is another way. That other way is called synthetic division. Okay, what does the word synthetic mean to you? Without math, fake or man-made or just manufactured or produced, right? So synthetic division is like, man-made division, okay? So here's what we're going to do. We're going to divide this by that using synthetic division. First, we have to set it up, okay? Check to make sure that all the exponents are present and in decreasing order. So the highest exponent here is 3, 2, 1, 0. We're good to go. Next, to set up the synthetic division, you have to create a little chart-looking thing like this. And what you do is, over here, you write down the coefficients of this polynomial. So for the x cubed, what's the coefficient? There is a 1 there. So I have a 1, then negative 3, then negative 2, and what's the last one? A 4. On the left, it's still going to go from that, but what you do is you take that, set it equal to 0, solve it for x, and that number, the negative 1, goes here. Okay? So what we did right now is we set up the synthetic division. Next, step 2. bring down the leading coefficient to the bottom row. That just drops down for free. Now, step 3. Multiply the value just written on the bottom by the outside number. In other words, whatever makes it down below gets multiplied by that red number on the left. So 1 times -1 is what? -1. Next, add the column created in step 3. So we're going to add this column. What are we going to get? -4. Okay, now, whatever makes it to the bottom row gets multiplied by -1. So what do I get? 1, 4. Add, what do I get? 2. Positive 2. Whatever gets multiplied by the bottom, whatever gets to the bottom gets multiplied by the -1. This becomes -2. I add, I get positive 2. Now look, this last number is your remainder. Okay, what about these numbers? These numbers are the coefficients of the new polynomial you created. So normally, what did our answer look like? It was like something x plus something x plus blah, blah, blah. So now, take a look. What was the exponent here? 3. When you do this process, the exponent goes down by 1. So now instead of 3, I have x to the 2, x to the 1, and no x. So the answer will be 1x squared minus 4x plus 2 plus the remainder of 2 over x plus 1, just like before. Okay? And this is the same thing as what we were doing, but it's synthetic division. So it gets you the same result as this, but in a different way. I call synthetic division the tofurkey of division. You guys know what tofurkey is? It's fake turkey. I mean, it works, but it's not the right thing, but it's not the real thing, right? That's what synthetic division is. I mean, it works, but it's not the real thing, right? Okay. Okay, I guess now I should call it like impossible division, like impossible burger, right? I don't know. I'll have to think about that. All right, let's do another one. So we're going to divide synthetically. Okay, put the chart. Are the exponents there in the right order? 3, 2, 1, 0? Yes. So I put the coefficients 1, 1, -4, 12. What number goes outside? A minus 1 equals 0, A equals 1. Okay. First number comes down for free. Anything that goes below gets multiplied by the red number. So 1, you add 2. Multiply, you get 2. You add, you get -2. Multiply, you get -2. You add, you get 10. Isn't it so much easier? Yeah, because before, I mean, you were really only dealing with the numbers. The, variables were coming along for the ride. Okay, so now, this was an a cubed. Now it turns into a squared. A to the 1, and the other one has no a, yeah. Because when you do division, it strips down the exponent by 1. Yeah, of course it makes sense. It's math, right? Yeah. Okay, so here we have 1a squared plus 2a minus 2 plus what over what now? 10 over a minus 1. Okay, all right, last one. We're going to do a little plot twist for the last one. Huh? Yeah, just a little bit of a plot twist. So take a look here. Remember how I've been saying, look, to see all the exponents are there and decreasing order. So look, I have b to the 4, 3, 2 is missing. Oh my God, 1 and 0. Since the b squared term is missing, we have to put a 0 in its place. So right here, the b squared is missing. So I'm going to have 1, negative 2, 0, 1, minus 8. Okay, don't undermine the importance of that 0, okay? It makes a big difference. Like, I mean, that's the difference between a right answer and a wrong answer, okay? So, what number goes out there? Positive 2.
But don't you bring down the 1?
Right, but I mean, like here.
Oh.
Here we're going to put a 2. Okay, yes, the 1 comes down. Multiply, what do I get? 2. Add, I get 0. Ooh, 2 times 0, 0. Add another 0. Oh my God, what's going on? When I multiply, what do I get to put up there? Another 0. When I add 1, multiply to get 2. When I add, I get negative 6 as my remainder. Do you see how instinctively I block that negative 6 out and make it a remainder so I know and I don't get confused later because I got a whole bunch of zeros to deal with now. Oh my gosh, what's going to happen? Yeah, Ella. By the what? Right. So the 1 gets multiplied by 2, you get 2. You add, you get 0. Multiply by 2, you get 0.
Oh, you just don't write it down.
So now, my exponents initially started out with a 4. So what am I going to start with now? A 3. So here I get b3, b squared, b to the 1, and no variable. So I have 1b cubed, 0b squared, 0b. I don't write that. Plus 1, and then plus negative 6 over b minus 2. Right? So whenever you get a 0 here, you just, skip it. But again, guys, look, these little guide things that I do, I don't do that to make the page pretty. I do that because they serve a purpose. Always write down b to the 3, b to the 2, b to the 1. When you're taking a test or a quiz, the stress of it is enough. Okay? So help yourself out. Write these down so you visually see what's going on. Okay? All right? Listen, I was working on some stuff yesterday, and I actually had to pull out my calculator to do something like 16 minus 4 or something because I was just so tired. Sometimes our brains are tired, and we need to help ourselves out. So, do this. Okay? Now, since this is fresh in your minds, we're going to start on homework, which is from the book. Yay!